All right. This is a scapular lecture, the muscles that influence scapular motion and position. Okay. Once again, just like with the shoulder, we're going to do a quick review. The scapula is so remember in the pelvic girdle, kind of pelvic girdle was more of a cement slab to anchor the skyscraper that's your spine. Scapula is very mobile. You can move the left from the right. They're not anchored together. The true start of your shoulder girdle is here, sternoclavicular joint. The clavicle comes out and attaches to the scapula here, the acromioclavicular joint. You have your shoulder joint, which is also attaches to the scapula. And then the scapula itself, the meaty body of the scapula, floats on your thorax. Okay? That's why they call it the scapulothoracic articulation, because it doesn't fit like a joint with a capsule and ligaments. It has to kind of free float, because as you move your scapula, it kind of floats around. I like to look at it as orbiting. It orbits the ribs. You know, the ribs are curved, the scapula is kind of curved, so it orbits, and that's how you get this kind of unique scapular motion. Remember, at the end of the day, the function of the scapula in terms of its motions is, in essence, to reposition your shoulder joint so that you get extra motion of your hand. By protracting, your hand goes forward. By retracting, your hand goes back. By elevating, your hand goes up. By depressing, your hand goes down. By upwardly rotating, you reposition the glenohumeral joint so that you could get your hand above your head at 180. That scapula, if your scapula didn't do this, about 60 degrees worth of this, your glenohumeral joint would only get here. It's because the scapula repositions itself that you can get your hand over your head. Not all of that motion comes here. Some of that motion comes there, repositions, okay? So once again, glenohumeral joint and scapulothoracic articulation, they work together. And so today's lecture is going to talk about the specific muscles that are pulling on the scapula to help make the scapula go up, down, front, back, spin up, spin down. Okay? Remember the motions of the scapula: scapula elevation, depression, protraction, retraction, and then once again, upward and downward rotation of the scapula. So we're going to have elevators, depressors, protractors, retractors. Now, this is a little it's tougher. It's different. With regular synovial joints, we had muscles that cross anterior, posterior. Because this is not a true joint, there's not true axes. In fact, the only technical axis here is the upward and downward rotation, and that axis falls within the spine. But in terms of elevation and depression, protract, there's a lot of general motion there. So it's more, the verbiage is going to be like muscles that pull up, muscles that pull down, muscles that pull forward, muscles that pull back, towards the spine, away from the spine, towards the head, very general kind of motion, directional cues. And as you're going to see, the circle is going to be different as well, okay? So good thing about this flat bone of the scapula is a lot of surface area for muscles. You see all this red and blue, lots of surface area for these muscles to pull on. So that's good. All right, let's get going with the muscles of the scapula. I'm going to go turn off the light and we'll get going. All right. The first muscle that I'm going to talk about is the trapezius muscle. Fascinated with the trap. Not that I haven't developed trap. I was just fascinated with it growing up and in school, because it made no sense to me until someone taught me how to make sense of it. But if you think about it, a bicep, a tricep, you know, straight line muscles make sense. But when you look at that, right, man, that's all over the place. Like, would you make up your mind where you want to pull? So again, different apple, banana, strawberry, sledgehammer. It's different. But it's super cool once it's explained to you kind of why it's all over the place. Fan-shaped muscle, right? Covering a lot of area so that all the fibers do something in common, but some of the fibers don't have to do what other parts of the fibers do, okay? So first thing I'm going to do is talk to you about what the fibers have that are different. The upper trap, the upper fibers. Some books refer to them in numbers. They'll have like 1, 2, 3, and 4 parts of the fan. For our class, we're just going to say if it pulls up, if it pulls in a direction of elevation, it's an upper fiber. And if it pulls in the direction of depression, it's a lower fiber. And then you have middle fibers that do neither. They just pull towards a direction, like these guys, just pull towards a direction of retraction. We're going to get to there. Upper fibers pull in the direction of elevation. Lower fibers pull in the direction of depression. So upper, lower fibers of that fan. All of the fibers have 2 things in common, which again is kind of neat, fascinating to me. All of the fibers are trying to pull the scapula to the spine, pulling in a direction of retraction. Scapula to spine. In addition, all of the fibers are pulling in a direction of upward rotation of the scapula. I'm going to explain how that works like this. Let's imagine I have my cell phone, and my phone is going to represent the spine, or at least this flat part is going to represent the spine of the scapula. We could use our imagination that the rest of the scapula is here, okay? But what I want you to notice is the upper fibers, this is a force couple, 2 different linear pulls that are working together to spin something. If you were, let's pretend this was a merry-go-round, you'd want one person on this end of the merry-go-round pulling this way to make the merry-go-round rotate like this, but the person on the other side of the merry-go-round wants to pull that way. This direction of pull plus that direction of pull is going to actually create the same rotation, same spin. Okay, the torque, the rotation will be the same. So back to this analogy. Good Lord, how'd that happen? Back to this analogy. The upper fibers are trying to spin the scapula in a direction of upward rotation. So, heck, even the middle fibers are trying to pull in the direction, if this is the axis. And then the lower fibers are also trying to pull the scapula in a direction. So you get all of these trying to do this, and you have these trying to do this. Upward rotation pullers, the trapezius. So function, all of the fibers, retractors, upward rotators. The upper fibers are elevators independently, and the lower fibers are depressors independently. But when they work together, they work in the same direction of spin. That's pretty cool. Okay. All right. I talked about the pectoralis minor a little bit in the shoulder lecture. The pectoralis minor is deep to the pec major. So pec major lives here. If you take it out, then you'd be able to see the little pec minor in the front. The origin of the pec minor is on some ribs, like 3 through 5, but who cares? We're just here to learn function. What does it do? It comes from the ribs, goes up and pulls on the coracoid process, which is part of the scapula. It's an anterior knob, little bony knob of the scapula. So the first function should be pretty obvious. Pulling in a direction of depression, pulling the scapula down. The second and third function is a little tougher. This is a two-dimensional picture, but it's a three-dimensional concept. What I mean by that is all you see is the straight down pull. What you don't see is the depth of the pull. The fact that the pec minor comes from anterior ribs to a coracoid process that is more posterior to its origin, meaning that it's trying to bring the coracoid process forward to meet up with the front of the 3, 4, 5 ribs. So this image is actually a three-dimensional image, and it's trying to pull the coracoid anterior forward. Now, what do we call something that pulls in the direction of forward of the scapula? A protractor. Pulling in the direction of protraction. I feel like I'm doing some kind of like little 80s heart bump dance. Protractor, depressor, protractor. The last function is the trickiest, but I'm going to explain why it's super simple. Remember how I said rotation of the scapula lies upon the spine somewhere, okay? So if this represents my scapula, spine back here, okay, I'm going to take it out. The coracoid process is more lateral to the axis. What I mean by that is muscles that pull this way are going to be upward rotators. Watch. Upward rotation of the scapula, downward rotation of the scapula. Upward rotation of the scapula, downward rotation of the scapula. The coracoid process is more lateral to the spine, meaning that when you do this, the pec minor wants to pull in a direction of downward rotation. It's a downward rotator. Stretch, pulling in a direction of downward rotation. So what does the pec minor do? Depressor, protractor, downward rotator. The next muscle that's on here is the serratus anterior. You think about serrated edges, serrated blades. You have serratus anterior, a serrated muscle that pulls the scapula forward. The serratus anterior starts on the ribs. That's if somebody has real low body fat, you can see those little finger-like projections on the ribs. And again, that was a muscle that always kind of stumped me. What the heck does that do? Does a lot at the scapula, okay? So what I'm going to do is I'm going to take a couple minutes to pull up a better picture of the serratus anterior so that you can really see how this muscle that starts on the ribs pulls the scapula forward. All right, I'm going to go with this one because it has I'm going to go with this picture because it has something that's very important. It has the origin laid out in dotted lines here, okay? That's something that my PDF pictures don't have. So again, serrated blades, serrated edges, you think like a knife, serrations, serratus anterior. So this muscle goes from the ribs to the vertebral border of the scapula, and its function primarily, I'm going to get into the other function, but its function primarily is to pull the scapula forward in a direction of protraction, a scapular protractor. Okay. Now, in addition to that, remember, upward and downward rotation, the axis is up at the spine. That's important. Spine is way up here. So look at how much of that muscle is underneath the axis. What does that mean? Let's pretend the scapula looked like this, and this was the spine. Well, if a majority of the muscle falls underneath the axis, it's pulling in a direction of upward rotation. So the serratus anterior, it's really kind of cool. The trapezius is kind of working the top part to pull in the direction of upward rotation, and the serratus is the bottom part, like pulling the legs out. You know, if someone would pull your legs out from under you, you'd rotate like this. Same thing. Serratus anterior is pulling the legs out of the scapula, and the trap is working on the top part in a force couple to trap. So all of those muscles are working together. And why is that important? When you're pressing and moving, and you need strong muscles to reposition that scapula to keep up with your strong shoulder muscles. Okay? So the function of the serratus anterior, a scapular protractor and upward rotator. And I'm going to show you how to see that in the circles. Okay, let's go to these muscles of the scapula. You have your rhomboids. Now again, plural, differentiating what plural means. When I talked about the pecs, plural, it meant right and left pectoralis major, or it can mean the right major and the right minor if we're talking about shoulder and scapula function independently, or it could be majors and minors, again, shoulder, scapula function. Rhomboids here is inferring of major and minor. The reason we don't necessarily differentiate them is because they're sister muscles. They have the same function at the scapula. So we'll refer to them as rhomboids. Okay, rhomboids, major and minor. So the first thing is, try to show you how these muscles work. Let's say this is the vertebral border of the scapula. Okay, these muscles, their first component of pull is trying to bring the scapula to the vertebra. So a retraction component, you can imagine that, pulling in a direction of retraction. But in addition to vertical pull, it has a horizontal pull, it has a vertical pull. So in other words, these fibers are trying to pull an inferior part of the scapula up. So the rhomboids are retractor pullers and elevation pullers. So they are retractors and elevators. In addition, those are too easy to see. This one's kind of more tricky. If this was the scapula, right, I'm drawing it out to show you. In terms of rotation of the scapula, it would be a downward rotation puller. Does that make sense? Serratus anterior, upward, rhomboids, downward. Downward rotation puller are rhomboids. In addition, you have the levatus scapula, elevation of scapula, pulling in the direction of elevation. But not only is it trying to pull up, it's going northwest, right? Up and across. So elevation, retraction, and also it has, especially when the scapula is upwardly rotated, it has a nice downward rotation pull to it. Okay, now, just to make sure we're all on the same page, these scapular muscles are muscles that directly influence the scapula by pulling on the scapula. Technically, I mean, guys, we could go down the rabbit hole a lot, but this is just giving you some important information, and you'll learn more about it as you go to grad school or as you learn through life. You have shoulder muscles that cross the scapula to get to the humerus. What I mean by that is if you pulled on someone's arm, if you pulled down on their arm, eventually the humerus would pull on the scapula and the scapula would pull in the direction of depression. So you have muscles that cross the scapula and pull on the humerus that would technically pull you in different scapular directions. These are just scapular functioning muscles that pull on the scapula. Okay? All right. Here's your circle. It is different. It is different because the scapula is different. Scapulothoracic articulation, not a joint. So we can't look at it in terms of a cross section. The easiest way to look at scapula function is to look at a posterior view. So this would be like we're looking at the skeletons. Look at the similarities. Right posterior view of the scapula, you see that triangle on the circle? That kind of represents the scapula. You see all those little arrows? I know, high tech, huh? That's the spine. So that shows you, hey, these muscles that are more medial are going to be trying to pull that closer to this, pulling in a direction. So these muscles here are going to be retractors. Well, the opposite of retractors, these muscles over here are going to be protractors. The top muscles are going to be elevators, and the bottom muscles are going to be depressors. And then you get into the rotation. So rotation this way would actually be about an AP axis, right? So upward rotators are going to try to spin this way, and downward rotators are going to try to spin that way. Okay. So let's compartmentalize. Who are our scapula elevators? Rhomboids, upper trap, levator scapula. Who are our depressors? Pec minor, lower trap. Who are our protractors? Pec minor, serratus anterior. Okay. Retractors are trapezius. Remember, this is another example of it's one muscle in different parts. So again, you can use a colored pencil to connect the upper trap with the lower trap. But our trapezius, levator scapula, rhomboids, and then you get into the force coupling action. Upward rotators are trying to spin this way. Downward rotators are trying to spin that way. Who are my upward rotators? Now, this is where I wish my grad student would have done the arrow a little differently, and for that, I apologize. These are spinning this way. These are spinning this way. This upper trap should be here, trying to spin in a direction of upper rotation, following the lower trap. So this arrow needs to be a little bit more obvious. Right? So upward rotators, trapezius, serratus anterior, downward rotators, rhomboids, pec minor, right? Levator scapula. So over the weekend, study functions of wrist, elbow, radiolus, shoulder, scapula. You can do the same thing with stretching here. How would you stretch an elevator? By depressing. How would you stretch a protractor? By retracting. Okay. How would you stretch a pec minor? Well, pec minor, if you know its function, it's a depressor, so I got to elevate. It's a downward rotator, so I have to upwardly rotate. And it's a protractor, so I have to retract. So if you went up to a door, call it a door stretch, and you get those three different positions, that would really lengthen that pec minor optimum. So again, a lot of useful information with knowing function, knowing direction of pull. Okay. All right. Text me, email me. If you have questions, I'll answer them. I'll clarify them. Okay. I'll do whatever you need me to do to make sure you guys make good grades. Y'all have a good weekend.